Hey guys, how you doing? It's Coach Scott again with Coach Scott Chemistry. Let's go on and let's start talking about molar mass. What does it mean? Well, again, it's a mass that we can measure. All right, it's not in AMUs, it's in grams. And our key thing we're going to use is our periodic table because the molar mass of an element, 1 mole of carbon has a mass of 12.011 because you have 6.02 times 10 to the 23rd atoms, and an atom has 12.001 AMU. So it makes sense that a mole of that would be that many grams. There's another way we can do it, but let's just accept it. All right. So what is the molar mass of iron 3 nitrate? There's the formula. Okay. So we write this formula. I've got 1 atom of iron, so I'm going to go ahead and write this down there. Put that back where it was. Okay. We'll go ahead and write that. We have 1 atom of iron. It's by itself. It's a metal. This is an ionic compound. Okay. What do we mean by ionic compounds? Well, that means that this iron gave up 3 atoms, or 3 electrons rather, to this nitrate to make it whole. But anyway, so how do I read this? This is a polyatomic ion. So this 3 here, I carry it across parentheses. That means I've got, for nitrogen, I've got 3 atoms of nitrogen. Okay, for oxygen, that means I have 3 times 3. That means I have 9 atoms of oxygen. So how do I do the molar mass? Well, I look at my periodic table and I see that 1 atom of iron has a mass of 55.845 grams. So I'm going to write that in there, 55.845 times 1, that's going to be 55.845 grams. Okay, nitrogen, looking at the periodic table, 1 atom has a mass of 14.007 grams. But I've got 3 atoms, so I'm going to multiply that. Let's go ahead and do that. So that's going to be 3 times 14.007, or 42.021 grams. I'll put that over there, 42.021 grams. Oxygen has a mass of 15.39, almost 16. 999. So that would be 9 atoms of oxygen. 9 times 15.999, 143.991. 143.9991 grams. So now to get the total molar mass of iron 3 nitrate, FeNO3, add it up. So that'd be 55.845 plus 42.021 plus 143.991. So I come with a grand total of, that should be grams per mole, is 241.857 grams per mole. So that means for every 1 mole, I've got 241.857 grams of iron 3 nitrate. Okay. So how many grams are in 12.3 moles of dinitrogen pentoxide? So this is a molecule. It's a molecular compound, which means that the nitrogen and the oxygen are sharing electrons. It makes it happy. So the formula for it would be, again, just trust me, dinitrogen N2O5 Di is 2 nitrogens. Pentoxide is 5. So how many grams are in 12.3 moles of dinitrogen pentoxide? Let's get the molar mass first of 1 mole. For every 1 mole, okay, I've got 2 nitrogens, and I've got oxygen. I got 5 oxygens for every 1 mole. All right, for every 1 nitrogen, it has a mass of 14.007 grams per mole. All right, and oxygen has a mass of 15.999 grams per mole. All right, let's do some math here. 2 times 14.007 grams, I got 28.014. 0.014 grams per mole. And then oxygen, 5 times 15.999, I got 79.995. Grams per mole. Add that up. So I have 28.014 plus 79.995. And that means that for dinitrogen pentoxide, that its molar mass is 92.009 grams for every 1 mole. So I've got 12.3 moles. Okay. So what's the mass for 12.3 moles? 1 mole is 92.09. So 12.3 moles would be 12 times 92.09. So let's see, 12.3 moles times the molar mass is going to give me, let's see, times 12.3. I'll get 1,131.71 grams. Not grams per mole, but that's grams. I got 12.3 mole. Hopefully that helps a little bit. Oh, let's do one more. Let's do grams for 1.34 moles of aspirin. Got to do the same thing. So let's see. I've got carbon, hydrogen, and oxygen. We got to get the molar mass. All right, so I've got 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen. Okay, I got to multiply that times the periodic table mass, 12.011 grams. Hydrogen is 1.0079 grams. And oxygen, again, is 15.999 grams. All right, we'll make that like so, just so we can see and add it up. So 9 times 12.011, I get 108.099. Grams per mole. Grams. And then 8 times 1.0079, I get 8.0632. Grams. That's a gram. And then 4 times 15.999. I get 63.996. 63.996. Add all those up, and that'll give me the molar mass of aspirin. Plus 108.099 plus 8.0632. So the molar mass of aspirin is 180.158, and we'll go ahead and put the 2 in there, grams of aspirin. I'm going to put ASP for aspirin. grams for every 1 mole. Now it's asking for how many grams are in 1.34 moles. Well, this is 1 mole. So let's see what I got to do. Well, multiply how many moles you got. 1.34 moles times 180. Whoops. Times 1.34. So, in 1.34 moles of aspirin, I should have 241.4, I'm going to round 12 grams of aspirin. Okay, not too bad, not too hard. And I think we can work through those and we'll be okay with that, right? So I'm going to do one on molar volume, and that'll be it for the evening. And then I'm going to post these and just something to study with. So this is Coach Scott saying, Hallabaloo, connect.